Let me unfreeze it here. Okay, create a function with zeros of x equals 0 with a multiplicity of 2, x equals 3i, and here's the hint. You will not get this hint on your midterm, and by extension of the conjugate pairs theorem, x equals negative 3i, and x equals negative 1. X equals 0 is a multiplicity of 2, and x equals negative 1. So regardless, let's not look at imaginary numbers first. Just put over zeros. So I have, right? So we have, right, x equals 0, and our multiplicity here is, multiplicity is 2, x equals negative 1. What's the multiplicity here? 1, okay? And then what are our, and let's say you were told that x equals 3i is a 0, okay? If x equals 3i is a 0, you need to know that x equals negative 3i is the other 0. So because if there is a 0 that's x equals 3i, you know there is another 0 that is x equals negative 3i. If there is a 0 that is x equals negative 3i, you know there's a 0 that is x equals positive 3i. So just by knowing that one 0 is x equals 3i, we have to know that the other 0 is x equals negative 3i. Now we need to find our factor. What is our factor if we have x equals 0 with a multiplicity of 2? What could be our factor here? If we have a 0, what would be our factor? All right, if you're having trouble with this one, let's try x minus 1. If you have x minus 1 with a multiplicity of 1, what's your factor? What's the factor? X what? All right, let's make sure we lift our heads up. Follow along. What? Okay, if your 0 is negative 1, if your 0 is x equals negative 1, your factor is x plus 1. And because it's multiplicity of 1, it's raised to the first power. If your 0 is x equals 0, then your factor is x minus 0 squared, because that's multiplicity 2. But then x minus 0 just simplifies to x. So we have a factor of x squared, x plus 1 to the first. Yeah. Yeah, so it would be x minus 3i and x plus 3i. These are our factors. So now we just have to multiply them to find our polynomial, okay? What's x squared times x? Right? So x squared times x is x cubed. And what's x squared times 1? What's x squared times 1? Come on, guys. Plus x squared. Now we need to do x times x. What's x times x? Yeah. Yes. X times x is x squared, and x times 3i. And she just treat I like a variable right now. Plus 3ix. And what about negative 3i times x? Minus 3ix. And what is I, by the way? I is equal to, what is I? Just conceptually. Imaginary numbers, but what is it equal to? Square, here's a hint, square root of what? negative 1. So, guys, come on. We have our midterm on Thursday. I want you to be successful. That means you have to stay focused and stay engaged. I mean, would there be a more efficient way to review than doing this? Okay. I is the square root of negative 1. Now, if I is the square root of negative 1, I squared I times I is equal to negative 1. Make sense? All right, so what is negative 3i times positive 3i? So negative 3i times positive 3i, negative 3i times positive 3i, that's, what's negative 3 times positive 3? Negative 9, and what's I times I? And that's negative 1, right? So that's equal to positive 9. So negative 3i times positive 3i is positive 9. Now what's 3ix, positive 3ix minus negative 3ix? What's 2, positive 2 minus 2? Right? So positive 3ix minus 3ix, regardless of what the heck this means, if they cancel out, it's equal to 0. So now I have x cubed plus x squared times x squared plus 9. What is x cubed times x squared? What is that? Yep, x to the 5th. What is x cubed times 9? Times 9x cubed. What's x squared times x squared? X to the 4th, and then x squared times 9 plus 9x squared. So I have x to the 5th plus x to the 4th plus 9x cubed plus 9x squared. All right, but now I have to see what the end behavior of this function is. What is my, and so I guess there's two ways to do it. How many of you guys remember the rules on degree and leading coefficient for end behavior? That sounds like it's no one. So let's go to Desmos. All right, x to the 5th plus x to the 4th plus 9x cubed plus 9x squared. X to the 5th plus x to the 4th plus 9x cubed plus 9x squared. So that's not 9x to the 23, that's 9x squared. All right. Yep. All right. So what's this end behavior like? What happens when x approaches negative infinity? What does f of x approach? Right? As x approach, you got it. You have to speak up for yourself and let me explain it better if it's not clicking in. As x approaches negative infinity, f of x approaches negative infinity. As x goes to the left, y is going down. As x goes to the right, y is going up. Y equals x cubed. All right, but it has to have the same end behavior as y equals negative x cubed. Okay? So now we have a problem. This wants us to create a function with those zeros, but it has to have the end behavior of negative x cubed. What can we do to keep the zeros but change the end behavior? What can we multiply? So this is the x cubed has the same end behavior, but we need to have the end behavior of negative x cubed. How can I keep the same end behavior with this function over here? What could I do to keep the same end behavior and the same zeros? Yeah. By having a negative sign, I have the same zeros, but now I've changed the end behavior. I've flipped the end behavior over the x-axis. So all I have to do to find a function with the end behavior is now I put a negative sign out in front. So that becomes negative x to the fifth minus x to the fourth minus 9x cubed minus 9x squared. All right. And that is our, oh, whoops. That is our end behavior. That is a function that has those zeros with those end behavior. An alternative method to do this for a multiple choice test is one for each answer choice. So this is alternative method. For each answer choice, this is for each answer choice. And if you are, if I need the engagement to just be higher. For each answer choice, plug in the answer choice into Desmos. Plug in answer choice into Desmos. All right. You need to select the answer choice that both has the right zeros, all right? It has to have all the zeros of the functions being asked and the correct end behavior, all right? End behavior. So if the function has any zeros that aren't the zeros that were given, or any of the end behavior that was not described, then you can eliminate the answer choice until you're left with the correct answer.